Well, ladies and gentlemen, we're going to tackle ourselves a monster topic here tonight. We're going to work on adding and subtracting rational expressions. And if you recall from the last few nights, a rational expression is just simply a fancy name for a fraction, and just happens to be that our fractions now contain variables and our numerators and denominators are polynomials and so forth. But so really ultimately we're revisiting an age-old topic, our arch nemesis from years ago. We're going to work on adding fractions and subtracting fractions tonight. Now, just a quick overview. Something they're going to do is they're going to give us a fraction like 5 over x, and they're going to ask us to add it to 3 over x plus 1. And you can just imagine all the work that's going to go into creating common denominators and stuff. But my goal tonight is to show you how you're going to end up with a final result of 8x plus 5 all over x squared plus x. And just all the work that goes into combining these two fractions into one new single fraction. So a quick review of adding fractions. Let's jump in that old time machine and go back a few years and just review, how did I add a 4/3 to an 8/3? Well, the good news is we could celebrate the fact that we do have common denominators here with the 3's, so we can simply go ahead and add the numerators and get a 12 while keeping the denominator the same. So we're really saying, well, 4/3 plus 8/3 is equivalent to 12/3, and then of course that reduces down to a 4. Or we could say, what's 4 over x plus 8 over x? Again, common denominators, so we combined the numerators but kept the denominator the same as it was. Or what's 6x plus 2 all over x plus 1 plus x minus 7 all over x plus 1. Again, common denominators, so we're going to go ahead and combine the like terms within the numerators and end up with 7x minus 5 all over that common denominator of x plus 1. But things started to get a little bit goofier when they asked us to add fractions like 4/3 plus 5/2. And everything came to a screeching halt because we didn't have those common denominators, and we said, well, I do believe that the common denominator shall be a 6. So what I did is I said, I'm going to multiply that first fraction by 2 over 2, which is a well-disguised what? Yeah, it's just a value of 1. But anyway, as I multiplied, the 2 times the 4 it gave me 8, and of course the 2 times the 3 gave me the 6. And then I came over to the second fraction. I said, well, the only way to get a 6 is if I multiply the top and the bottom by a 3. Numerator gave me a 15, and the denominators gave me that 6 that I wanted. Now, once I got those common denominators, the problem became very easy, and we ended up with 23 over 6. So now that we've gotten the rust off from earlier years, let's go over the two monster guidelines that are going to really keep the train on the track, so to speak, tonight. Our fractions must have what? Common denominators. And I can't stress this enough. Probably 80% of our energy tonight is simply going to go into the idea of identifying and then creating that common denominator. And number 2, our denominators can only be changed by multiplying the overall fraction by a value of 1. By multiplying the overall fraction by 1. And that's what we're going to keep going back to. It's not going to maybe necessarily look like a 1, but it's ultimately going to have a value of 1 every time we multiply. Alright, so we're going to dive into our first live problem. We're going to add two rational expressions. Okay, we've got a rational expression right here. It's just the quotient of two polynomials, and the same over here. We're going to add them together. Of course, the bad news is we do not have common denominators yet. So, now before we even begin our discussion on common denominators, I just want to do a quick overview on what I call domain restrictions. Okay, and this is one of the things we're just going to get in the habit of always doing, and it's going to pay off over the next couple of weeks in a big way. But what are the domain restrictions? Okay, in other words, do you remember how our denominators cannot be divided by 0? So I'm going to say in both of these cases, x is not allowed to be a 0 just by looking at the denominators only. And we'll continue to ask ourselves what the domain restrictions are in each of the problems tonight, and I think you'll get better at that. So just start to build good habits. Now anyway, I need common denominators, and so I'm looking at the 4x and the 6x, and I think my common denominator is going to be a 12x. Alright? So I've identified my common denominator. Now I just need to create that. So I need to multiply by a value of 1. Keep telling yourself that. Multiply by a value of 1. Multiply by a value of 1. Now, how do you turn a 4x into a 12x? Well, you've got to multiply by 3. And whatever we multiply the bottom by, we're going to multiply the top by the same. And that right there, ladies and gentlemen, has a value of 1. Now, go ahead and distribute your 3 through the numerator. and you're going to end up with 6x minus 15. And of course, 3 times 4x on the bottom gave me the 12x that I was shooting for. All right, on the second one, how am I going to create a 12x from a 6x? Well, we're going to multiply by 2 over 2. Again, we're multiplying by a value of what? 1. So I distribute the 2 here to both terms, and I'm getting 8x plus 4, and of course on the bottom, the 2 times the 6x gave me the 12x I was shooting for. Now that we've got common denominators, life is easy. We're just going to combine the numerators, and the 6x and the 8x give me 14x, the negative 15 plus the 4 gives me negative 11, and ladies and gentlemen, this is my final answer. There is no GCF in my numerator, there's nothing to factor out, therefore there's nothing to reduce. Okay, first things first, let's ask ourselves domain restrictions. What is x not allowed to be? Simply look at your denominators, set them equal to 0, and we decided that x is not allowed to be 0 in this case, because if I did substitute a 0 right there, the whole denominator would turn into 0. So, anyway, what do you think the common denominator should be? I believe that it should be a 10x. That's the smallest monomial that both of these denominators divide nicely and evenly into. And so how am I going to create these? What am I going to multiply the first one by? I'm going to multiply by 2 over 2. Okay? I'm going to distribute here on the top, and that's going to give me 8x minus 2. Of course, on the bottom, 2 times 5x gives me the 10x that I was shooting for. On that second one, all I need to do is multiply by x over x. Again, all that fraction does is it has a value of 1, just like the first one over here did. And as I distribute this x to both terms, notice distributing is a major theme here tonight. I get x squared plus 5x, and of course on the bottom, I get the 10x that I was shooting for. Okay, now life's pretty good. We're just going to combine the like terms in the numerator. X squared plus 13x minus 2 all over 10x. And ladies and gentlemen, that's our final answer, okay? If you need to put a little asterisk right here, just make a note that we are combining what? Once you create those common denominators, we're combining all the like terms in the numerator. And notice, of course, the denominator does not change. First things first, domain restrictions, set your denominators equal to 0 and solve. And I'm going to decide on both of these that x is not allowed to be 0. So we've seen the same outcome in these first 3 problems. I promise you we're going to have some more interesting domain restrictions later on. But anyway, so we need to identify the common denominator, and I believe it's going to be 4x squared. Okay, 4x squared is the smallest monomial that both of these denominators divide nicely into. What am I going to multiply the first fraction by? I'm going to multiply by x over x. That's going to give me a 3x on top. And if I multiply those guys, the denominators, I'll get the 4x squared I was shooting for. The second fraction, I'm going to multiply by 2 over 2, again, which just has a value of 1, just like the x over x did. And let's see, numerators give me a 2, and the denominators give me the 4x squared that I was shooting for. All right, now we're going to just combine the numerators, adding like terms, but there are none, so I'll just say 3x plus 2 all over 4x squared. Ladies and gentlemen, that is our final answer. Okay, real quick recap of what we've accomplished so far. In these first 3 examples, they were relatively easy because all of the denominators were what? What did all of the denominators have in common? And you've got those 3 problems in front of you, and you can kind of, quickly look over them and see what they have in common. All the denominators were monomials. All right, and that's what made them relatively easy. And of course, relatively easy. I never want to say that they're too easy. Now, once those denominators, though, become binomials, like we're going to start to see, or even trinomials, okay, things are going to get a little bit crazier, but they're still very doable. And the key is we have to factor these denominators first. That's what I want to emphasize here, is that we've got to get them factored completely before we identify the domain restrictions and before we identify our common denominator. So let's go try some. Okay, so as the directions imply, we need to get these rascals factored first. And so that first fraction is really 4 over 5 times the quantity, y minus 3. How did I factor it? Well, by golly, I pulled out a GCF right there. All right, plus 5 all over. I'm thinking y plus 3 times the quantity y minus 3. What technique did I just use? I used a difference of 2 perfect squares. And now we have it factored completely. Now, what are our domain restrictions? I'm going to say there's two restrictions, okay? If I set the first denominator here equal to 0, I'm going to say y is not allowed to equal 3. And you'll notice then on the second rascal there, y is not allowed to equal negative 3. So those are the two restrictions we're going to put on our domain, because that's what makes them undefined. Now I'm going to try to identify who my common denominator is. In this case here, it's a little harder to interpret, but I want you to tell yourself this. Our common denominator is going to consist of one of each factor you see. So I'm going to need a factor of 5. I'm also going to need a factor of y minus 3, and I'm also going to need a factor of y plus 3. Okay? So I'll repeat that. Your common denominator is going to consist of one of each factor you have in all of your denominators. And now we need to create that common denominator. We need to multiply by a value of 1. So you ask yourself, well, what's that first denominator missing? It's got the 5 already. It's got the y minus 3. What doesn't he have? Well, he doesn't have the y plus 3. So I'm going to multiply the top and the bottom by y plus 3. Remember, what I have here in blue has a value of what? Exactly, a value of 1. Now I'm going to have to make sure I distribute the 4 and get 4y plus 12. All right, moving on to my second fraction. Well, he's already got the y plus 3. He's already got the y minus 3. So what in the world is he missing? Well, he's missing a factor of 5. So I need to multiply the top and the bottom by 5. Of course, what I have in blue here has a value of 1, and I get a 25 for my numerator. Now that we've got these common denominators, all we have to do is add the like terms in the numerators, and we're going to end up with 4y plus 37, all divided by, yes, keep the same exact denominator you originally had here, and that, ladies and gentlemen, is our final answer. So as we said at the beginning of the video tonight, we do have ourselves a very challenging topic, but I think we're doing quite well so far. And what's our first move going to be on this next example? Oh, yes, we've got to get the denominators factored as much as possible. So I'm going to go with x minus 5 and x minus 4, simply because those two numbers add up to negative 9 and multiply to positive 20. And on the second denominator, I'm going to go with x minus 4 and x minus 2. Again, they add up to negative 6 and multiply to positive 8. What are your domain restrictions? All right, I'm going to say x is not allowed to equal 5, x is not allowed to equal 4, and x is not allowed to equal 2, just by looking at all the denominators and setting each factor equal to 0. Okay, what do you want your common denominator to be? Remember, it's going to consist of one of each factor that you see. So I'm going to need an x minus 5. I'm going to need an x minus 4, but I don't need to repeat the x minus 4. I just need one of them. And I also need the x minus 2. Again, it's consisting of one of each factor that we see. Okay. All right, now we need to create that common denominator. What am I going to multiply the first fraction by? In other words, what's he missing? He's already got the x minus 5. He's already got the x minus 4. What's he missing? Aha, the x minus 2. Again, what I have here in blue has a value of what? Yes, 1. Now what we're going to have to do here is we're going to have to FOIL the x minus 2 with the x minus 3. And I'm going to end up with x squared minus 5x plus 6 by the time we finish our FOILing. The second fraction, what's he missing? Let's see if I can slide the screen over here a touch. Let's see. I believe that he's missing the x minus 5. So I'm going to multiply the top and the bottom by x minus 5. Distribute your 2 and you'll end up with 2x minus 10. And at this stage of the game, we are almost done. We're simply going to combine our numerators by combining like terms. I end up with x squared minus 3x minus 4 all over my common denominator of x minus 5, x minus 4 times the factor x minus 2. Ladies and gentlemen, can we do any more work? Waha! Well, this is the first one where I've had a numerator that is factorable. So I'm going to go ahead and I'm going to, whoa, hang on there. Make sure I get the pen going here. All right. So if I factor the numerator now that I've got it all combined into one fraction, let's see. I think we're going to get that. And my common denominator is this. So what do you see canceling now? Oh, I think that was supposed to be a 2. I made a little typo there. X minus 2. We're going to cancel the quantity x minus 4. And my final answer, now that I'm finally done, x plus 1 all over x minus 5 quantity x minus 2. There's my simplified single fraction. We're all set. All right, now we've talked a lot about adding, and now we're ready to talk about subtraction. The good news is subtraction is exactly the same as addition. The only difference is going to be our first move, and here's how we're going to approach that. We're going to change the operation to addition while distributing a -1 through the second numerator. All right, that's how we're going to approach this. And then, other than that, it's exactly the same as what we've been doing. We're just going to get more practice with it. So, for instance, on this particular example I've already got common denominators just so we can practice changing it to addition while distributing a -1 through the second numerator. Now, once you do that, it's exactly the same as what we've been doing. I'm simply going to combine the like terms and end up with 2y minus 5 all over x. And that's all there is to it. Again, another really quick practice. Good news is, yes, we already have common denominators, so I'm just going to change my operation to addition while distributing a -1 through that second numerator. Now combine your like terms, get 4y plus 1 all over x plus 4, and you're all done. All right, now I want you to kind of put yourselves in the teacher's shoes here. The student has worked out this problem, they've submitted it to you, and it's your job to decide whether they've done it correctly or not. And I'm going to challenge you with the idea of seeing if you can find the error. Now, what you have over here is, I don't want this to distract you. This is the domain restriction the student put on there. Okay, and I'll just abbreviate there a little bit. Okay, so don't worry about that. I just want you to look at this problem right here and ask yourselves, would you have solved it the same? Okay, can you find the student's error? That's my question to you. Well, let's see if we can see anything. Did they change the operation to addition? Yes, they did. Did they distribute a -1 throughout the entire second numerator? They got the first term, but right here's the error. This shouldn't be a +5 anymore. That term should be -5 right there. There's the error. Again, I've got one more real easy problem for you before things start to get crazy. The good news is we do have common denominators, so what I'm going to do is I'm going to change my operation to addition, and I'm going to distribute the -1 throughout those terms and combine like terms. I'm going to end up with 2x plus 4 all over x squared minus 4. Now the trick though is, now that you've combined two fractions into one fraction, ask yourself, am I really fully simplified? Well, I believe we can pull out a GCF in the numerator. We can use a difference of two perfect squares in the denominator. And booyah! Cancel those rascals and you get 2 over x minus 2 as our final answer. Alright, on the second one, and again, I got away from my domain restrictions. I should have said x is not allowed to equal plus or minus 2 just by setting the denominator equal to 0. On the second example, I need to get these denominators factored completely while I change the operation to addition and negate that second numerator. So let's see. Difference of two perfect squares, 2x plus 1, 2x minus 1. Alright, and then I'll pull out the GCF of 5 and I'll get a 2x plus 1. What are your domain restrictions? X is not allowed to equal 1/2. X is not allowed to equal -1/2. Alright, let's see. What's your common denominator going to be? Let's go with this. Let's say I need a 5. I also need a factor of 2x plus 1. And I need a factor of 2x minus 1. And of course it's going to be the same here for the second fraction. And trying to keep this as neat as possible, but it's getting a little sloppy. Alright, what do we multiply the first one by? Well, let's see. I'm going to multiply by 5 over 5, which has a value of 1. Distributing, I'll get 5x minus 15. The second one here, I'm going to multiply by 2x minus 1 all over 2x minus 1. Of course, has a value of 1. Distribute the -2, we'll get -4x plus 2. Now all I got to do is combine my like terms. And let's see, I've got 1x minus 13. Good news is that cannot be factored. So this right here is going to be my final answer. I know it's already simplified as much as it can go because that numerator did not factor, and we are donezo. Okay, another subtraction problem. I need you to change that operation to addition right away and distribute through or negate that second numerator. Now we're going to get this rascal factored as completely as possible. X plus 2, x minus 2. So we're really building some good habits. We're staying very organized. Everything's crisp and clean. And let's see, how about x plus 10 and x minus 2, because they add up to positive 8, multiply to -20. Alright, what are those domain restrictions? I'm going to say that x is not allowed to equal -2, x is not allowed to equal positive 2, and x is not allowed to equal -10 real quick. Alright, common denominator. We're going to grab one of every factor we see. We need an x plus 2, we need an x minus 2, and I need an x plus 10. Again, our common denominator consists of one of each factor we have in all of the denominators. So what are we going to multiply that first fraction by? What's he missing? In other words, he's got the x plus 2, he's got the x minus 2, but he's missing the x plus 10. So I'm going to multiply the top and the bottom by x plus 10. Distributing that x gives me x squared plus 10x. The second one, what's he missing? He's missing the x plus 2. So I'm going to multiply the top and the bottom by x plus 2. Distributing that negative 6, I get negative 6x minus 12. And here comes my favorite part. All I got to do is combine the like terms in the numerator. I get x squared plus 4x minus 12. Uh-oh, I feel some simplifying coming on here. So let's see what we got. Now, this is the first time that I've combined it into just one fraction. So now I'm going to ask myself, can I do any more simplifying before I, box it up and claim that it's my final answer? Well, I believe that numerator can be factored a little bit. We'll call it x plus 6 and x minus 2. Alright, so just before you think you're done, ask yourself if this numerator can be factored, and that's at the moment after you combine it into one fraction. Now we're now going to cancel the x minus 2's, and I'm going to claim that x plus 6 all over x plus 2, x plus 10 is my final simplified answer. Well, by golly, if you haven't done it yet, this is an outstanding chance to try one on your own. Hit that pause button, see if you can hit each step all on your own here, and don't worry about any mistakes, because if we're going to make mistakes, this is the time to do it. But what I'm going to do is I'm going to go ahead and I'm going to change my operation to addition. I'm going to change and negate that second numerator. I'm going to get everything factored completely here. So I'm looking at x plus 4, x plus 1, and plus, let's see, negative 8, and I'm looking at x plus 8, x plus 4. So what are my domain restrictions really quick? X is not allowed to equal negative 4, x is not allowed to equal negative 1, and x is not allowed to equal negative 8. Other than that, everything else is fair game with regards to the domain. Now, my common denominator is going to be, let's see, I need the x plus 4, I need the x plus 1, and I'm going to need the x plus 8 on each denominator here. Alright, it takes a little while to set these up, but Rome wasn't built in a day, so to speak, so good things come. And I'm going to multiply the first one by whatever it's missing, which happens to be the x plus 8. And everything that I have here in blue, again, has a value of 1. I want you to really understand that. We are going to FOIL these two binomials, and we're going to end up with x squared plus 6x minus 16. And the second rascal here, what's he missing? Looks like he's missing the x plus 1. So I'm going to multiply top and bottom by that, distribute the negative 8, and we get this. Now, my first obligation right now is to make sure I combine these two fractions into one fraction first. So do not worry about simplifying anything yet. Combine the like terms. We're going to get x squared minus 2x minus 24 all over that beautiful common denominator we've been talking so much about. And now this is the first time you want to think about simplifying. This is the first time we've combined it into one fraction. Ask ourselves, can that denominator be factored at all? I think we can hit it with x minus 6 and x plus 4. And if you compare that to your denominator, we do have a few things that will, or at least one quantity here that will cancel out. We're going to cancel the quantity x plus 4, and my final answer is x minus 6 all over x plus 1 times x plus 8. So there it is, ladies and gentlemen, our final answer. Well, before we call it a night, I wanted to throw a multiple choice question out at you, and a lot of times we do use a different strategy when dealing with a multiple choice. We're certainly looking for the most efficient path. And there's nothing wrong using the strategy we've spent the entire video showing you, but I want to show you a new trick here tonight. I'm going to let you pick your favorite number in the world. I want you to let x equal your favorite number, whatever it happens to be. Now, my favorite number happens to be a 4, so I'm going to let x equal 4, and what I'm going to do is I'm going to substitute that into the original problem. Now, as long as you have an updated calculator, this is where I love to use alpha y1. That's going to take you to the F1 menu, and I choose choice number 1, which is my numerator over my denominator. And when I did that, and I substituted a 4 in for those x's right here and right here, this is what I got. So I got 1/12, or I should, let's do this. Let's put it up here. I got 1/12. All right, and that's after, of course, it was like 0.0833 and it repeating, and I converted it back to a fraction. So now what I'm going to do is I'm going to substitute a 4 in for all of these other x's with the idea that one of them is going to give me an answer of 1/12. Then I'm going to continue to substitute that 4 until I get my answer. So going through them one by one, the first fraction, substituting the 4 gave me 4/3. That was not a match. The second one gave me, 1 all over -12. That was not a match. Choice number 3 gave me 1 over 12. Ding, 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 ding. There's our winner. Now just to confirm that that's the only one that works, we're going to try number 4, which gives me 4 all over 15, and that is not the right answer. So all I'm doing is I'm letting you pick your favorite number, substitute it in for all the x's, and see which one gives you a winner.